So good morning to all. So you want to
Good morning,
complete
sir.
that some exercises on these the concept of values and returns. So I project this one. The fifth one you must everyone take down in your exercise book these some and you follow that the steps to answer this question. You must do the exercise in your exercise book. Mhm. So how long it will take a double 1,000 rupees if it's grow at 12% annually. So this is a knowledge about how that the interest rate is used to calculate that is the required amount. So how long will it take to double 1,000 rupees? If it grows 12% annually. So you must apply this the time value concept to this kind of problem. So you want to identify the required component of this the time value concept. So the question how long will it take to double 1,000 rupees? So you take the 1,000 rupees. So you want to recognize the 1,000 rupees as the today's values. So it is present value. 1,000 rupees is identified as a present value. And interest rate. Interest rate is I 12% or 0.12. Then the other things you want to know the number of periods you don't know. So actually this is a question has been asked to calculate the n values. Number n is equal to how much? Then what else you want? Double the money. So you have the future value. Future value Fn. You should define it's 2000. So you can have the idea of that. Uh, you want to record that the future value Fn equal to Fn equal to present value into the future value factors 1 plus I to the power n. So if you can apply that, you can get it the n values. So you should apply some the techniques and procedures to answer this question. So it is not a simple question. You want to go through some steps. Then you want to give that as the exact answer to this question. So answer is 6.11 years. 6.11 years. So you follow that as the steps as I project here. You take down in your exercise book. So P0 is identified as 1000. I is 12%. To identify I is 12%. N is you should know. Then you want one thing more, that is Fn. Fn you should have the 2000, double the money. So then you can apply this formula, present value concept. The future value is equal to present value interest, future value interest factor. So you can substitute 50,000. Future value interest factor is not known because you don't know the number of variants. Only interest is known, 12%. But when you are getting that the results, it should be 2000. That is, Fn is should be equal to 2000. Then what else you can go? Right. So you can rearrange the formula to get that subject present value interest factor. N is equal to 2000 over 1000. So 2.000 would be the required present value interest factor. So you want to use the table value to get at what period at a 12% interest rate, the two is equal. But you don't have any the exact amount equivalent to 2. But you have the the close amount 1.9738, 2.2107. So you can observe from the present value table, present value table. Future value table, the A1 table can be used. So where you can find that, search for this factor at 12%. At 12%, so you come across nothing. But at the year 6, you can have it 1.9 the 1.9738. So you take it. You take it like this, 6 period. Then in the next period also you can take it 2.21 not 0 at the 7. So the 2 will be prevailing between the 6 and 7. 6 and 7th year, which gives the double the money. So what can you do it? You can take and divide by these 2. Oh, that's wrong approach. You must use the approach is called you must call that approach is called the linear interpolations method. Linear interpolations method. So what do you mean by linear interpolation method? Linear interpolation is a method of curve fitting using the linear polynomial to construct to new data point within the range of a discrete sets of known data points. The interpolated values are commonly used for filling the gaps in the table. If the two known values, say x and y or y to x, then the y value of some points can be calculated like this: y1 plus x minus x1 into y minus y1 divided by the x2 minus x1. This is the formula that you want to apply. So you learn this. So in the web it's available. You can learn it. So I can demonstrate here. So you get that as the values f6 at 1973.8, not exactly 2000. But at the year 7, you can get more than double, 2210. So you want to find out the date, exact year where that you want to get 2000. So this is a formula that you want to apply, as I have mentioned here. So this is the basic formula you want to take. So it is in the straight level, straightly it's given, but you want to put it in the fractions like this. So how can you do that? You start with that as a lower rate. 6 is there. 6 is there. Then you want to take the fractions. This is a process of linear interpolations. 7 minus 6. 7 minus 6. That is x minus x1. 2 points are there. X minus x1. You start with the y1. Y1 plus the 2000 is the maximum 7 minus 6. The range between this lower rate and the higher rate. You take the required one. Required is the 2000. But at the uh, lower rate, it's 1973. You get that it's a difference. You get the difference as x minus x1. Then you want to divide this one by the future value at a higher rate, 2210 points minus lower rate. Lower rate is there. So you find that this range, then you can get it the value 6.11. So it can be put in the formal ways. 6 years and 1 month and 10 days. 6 years, 1 month and 10 days. How can you convert it this one? You want to take a 0.11 multiplied by 12. So you can get 1 month. Then you deduct uh, So if you take the out of 6.11, 6 indicate the years. 0.11 indicate the year again. 0.11 year. You want to convert into 0.11 year by taking multiplying by the months in a year. So you can get 1 month, 1 month out of this. Then the other difference is there. That is 0.32. So you can multiply it by days, 30 days. So you can get 30 days or 31 days you can take. You multiply by so nearly 10 days. 9.9 days, 10 days is gone. So these are steps you want to follow. Present you want. So you must give some more steps in getting your answer. So after substituting this one, so you want to show it in the next step that what is the summary of it. So you want to separate that 6 plus 0.11 is the linear interpolation. So at the year 6 year run 1 month and 10 days, you can get the money double. Sometimes if you ask that to find out that the year which takes to double the money at the nearest year, at the nearest year, you can answer it as a 6 year rather than the 7 year. But if you want to answer, you want to answer the exact time. So you want to go for this kind of linear interpolations method to get the results. That's the thing. So you can take down this next one. A person bought a share 15 years ago for 10 rupees. It is now selling. It is now selling for 27.6 rupees. 27 rupees and 60 cents. What is the compound growth rate in the price of the share? So the answer is given as 7%. But you want to uh, work out to get the answer. So you learn that the question. 15 years ago, 15 years ago, the price of the share was 10 rupees. Now it is selling for 27 rupees. So how can you now can you take that 27.60 rupees as the present value? So you want to equate the situation that now the value is 10 rupees. Now the value is 10 rupees. After 15 years, after 15 years, you will have the value 27.6 rupees. 27.60 rupees. So you set that at the 27.60 rupees as a future value. Future value F15. You defined F15 would be 27.6. P0. present value zeros would be 10. N number of n, 15. I, you don't know. Also, you want to find out the interest rate. That's the question. So you follow that steps for this question. You define F0, 10. I, you don't know. N, 15. F15 is given 27.6. So what is the concept you can apply to find out this one? Again, the future value of lump sum. Future value of lump sum should be applied. So this concept should be applied. Right. So you substitute P. Then the present value interest factor 15. I, you don't know. But the results would be 27.6. Now you can take the subject present value interest factor for annuity in the equation. So it is 2.7600. So you can check that at the table value whether it is available at what rate 15 years. At 15 years, you go for this 2.77 years. It is available here. Luckily, you have this number 2.7595. At 7%, it is there. So you can straight away answer your question simply. That is the future value interest factor at the 15th year, 7% it's become equal. So your answer, therefore, I. Therefore, I is equal to 7. Suppose that in some variation you can find. So you take the variation on that. That the Persian bought a cha 15 years ago for 10 rupees. It is now selling for 30 rupees. So what is the compound growth rate in the price of the share? 30 rupees. 30 rupees. So B0, so take on the 10 rupees. Interest rate, you don't know. Right, you can observe that when you are answering this type of question, the variation, you want to have this future value interest factor equal to 3. So in your table, you search for that the value at 3. So you can't find the exact value. But it is between these two. 7% and 8% is there. So you want to set that at 7%. At 7%, you can get that as a value 2.7. 2.76. 7590. At 8%, at 8%, you can set this is put in the table 15, 3.1722. 3.1722. So you want to set a linear interpolation like this. F15. Equal to 2 rupees at 2.759. 2000, sorry, 27 rupees and 90 cents. Yeah, see, 0.9. Second, you want to take the two values. Second, also you can take the 10 rupees into this value 3.1722. 3.1722. So you can get it 31.722. So you want to set a linear interpolations. Right. Instead of end, you put I. I is there. starting point 7. Then the maximum 8 minus 7. The two rate you have as 2 rate, 7 and 8 you have as it. So the record value the D. The low value. Low values you want to get 27.79, yeah, 59. And the maximum, low value and the maximum value. So how much you can get? 3172. 3172. And the rate would be 27.59. So you can have 7 plus these fractions. So you can use a calculator. 30 minus 259. So you can get the answer for this question. Uh, 7.26%. So this is done by this the linear interpolation applications method, right? So the earlier you learned that in the how can calculate this one 7.25 the growth rate. The compound growth rate the half price 2.7 7.26. So you can check it with that any obligations. The calculator also you can check it. So, so you can apply the scientific calculator. 1.726. 1.726 x to the power 15. Then you can get that at the value 3.5. That's wrong. 1 point not sure. Not 126 to the power 15. There's an error. No? So, we So you can confirm that it is so there has to be some approximation to get that exact 7.6%. 7.6% could be arts. So this is arrived at by these procedures. Then you can learn the other applications. 'Take down this question. The person is borrowing 20,000 to buy a low income group. He pays in equal installment 25 years. And per person interested on outstanding balance. What is the amount of installment? What shall be the amount of installment if quarterly payments are required to be made? So in this question, you can observe that a person is borrowing 50,000 to buy a low income group house. Loan is obtained like that. So how can I identify this 50,000? It's a P value or F value, present value or future value. So it's to be identified as a present value. Number of periods equal installment 25 years. So N is 25. Interest rate 4%. I is 4. What do you want to find out? What is the amount of installment? Installments mean the annuity. Annuity A should be found out. So what type of time value concept you can apply to find out this? Annuity is not lump sum. This is annuity. So you can take that the future value of annuity or present value of annuity. Future value of annuity or present value of annuity. What is the amount of the installment? So this is answer is given like this. So you want to check it. There are two questions. One is there. So you identify the P is equal to 50,000. I is 4%. N is 25. You want to find out A. So what is the concept you can apply? This one. Present value is today. This annuity is coming in the future, discounted by the factor. Present value interest factor for annuity. So you can substitute the 50,000 for P. For N, you don't know. For present value annuity interest factor for annuity, you want to have the reference to the period. A3 A4. Present value of factor for $1 of annuity. Yeah. At 4%. So the interest 25 years and 4%. So you go to the 25 years and 4%. You can find the 15.622. 15.622. The present value interest rate. Then you can take substitute this value. You rearranged the A is equal to 15,000 divided by this. So the annuity is obtained like the 3,200 rupees and 60 cents. You can check it. $3,200 is obtained. So the second answer, what shall be the amount of installment? The quarterly payments are required. So what do you mean by quarterly payments? So this is annual payment. The 3,200 is the annual payment. But the quarterly installment is required to repay. So at the time you want to do some adjustments. What is the adjustments? You want to divide this interest rate by 4 quarters. So it becomes as 0.01. Likewise, you want to increase the number of installments by multiplying with the 4 quarters, 25 days. So the period, number of period become 100. So you want to find out the annuity in this case. So again, there you can substitute the n is 100 at 1%. This time, present value interest factor to be calculated. So if you go to the table, you can't find it. The table given, find. So what can you do? So you can use your calculator to generate the factor using this equation. That equation is given like 1 minus 1 over 1 plus k to the power n over k. So you can find that this is 63.2089 at 1%. You can use your calculator to get that value. Or check it with that with the Excel. Yeah, the value is coming as 63 point not to 8 now. Good. So this is correct. So substituting this one, you can find a value 793.29. So you can use the calculator straight away. In your scientific calculator, you can apply that formula given in the table and substitute all the figures as given here. Then you can get that as the value 63 point. Uh, Not 2899 or 289. So it is confirmed that this value is correct. So one more example, you can apply that. You take down this. A company has issued a debentures of 1 million to be repaid after 10 years. How much should that company invest in a sinking fund to earn 12% in order to be able to repay the debenture? So in this case, you can identify the debenture 1 million. What type of value is it? This is a future value. As issued a debenture to be repaid after 10 years. So this is the problem is that you want to have this money after 10 years, 1 million. So you want to set a fund. You want to set a fund by investing some amount of money periodically. That is annuity in a investment, earning a 12% interest. Then by the end of this the 10th year, you will have the money equivalent to this debit. Then by the time you can redeem it. So question has been asked there, how much should the company invest every year? Up to 10 years, it should be done. So the answer is given as 56,984.28. So how can you work out on this is explained here. You follow the step. So you take that F10 is equal to 10 1 million. So I is 12% and 10 annuity you want to find. So what is a formula that is the present value and the time value concept you can apply? Future value of annuity. Future value of annuity. So future value is annuity of the future value of interest rate of annuity should be applied. If you apply the present value of interest rate of annuity, that's wrong. Because at the end of the 10th year, you should have this one, not now. Even though this is the problem that the money is obtained now by issuing, but the repayment should be done again. So it is not done. The interest would be issued separately, but it's the capital amount. Capital amount will be uh, to be repaid as a lump sum. So the 10% interest should be there. So it is like that. Say the government is borrowing 1 million money from a country, foreign country, by issuing bonds. The bond is called the debenture, promising that after 10 years, we should be repaying that money. But for a 10 years, we should pay the interest. We should pay the interest. Uh, Annually, it should be done. It should be paid in dollars. So the government has paid that as a money, and only the interest by dollar. But at the time the maturity is coming, the $1 million would be paid immediately. But the government has no money, has no dollar to pay. That is the crisis is there. So this is because of this the fund arrangement. Fund arrangement. So the government should have done that to establishing a sinking fund, equivalent to the borrowing amount, and they would have invested the fund in a profitable ventures. Profitable ventures. But the government has failed to do that. They have obtained the money and they invested their money in the public expenditure, which are not profitable, which are not generating money. So there will be no fund also to be created. The fund has been created, then there will be no problem. Every foreign loan should have been paid on time. So that now the government has the problem of losing the credit worthiness among these creditors. So this is a kind of arrangement that the company is doing. Company is doing. So you can substitute that as the figures, but you want to obtain this value from the table. That is future value. Table 2 should be taken. Future value of interest rate $1 annuity at 12% for 10 years. So you can observe that it's 17.549. 17.5487. 17.549. Oh, 89. It's so. So you can find that we divide it approximately 56,984 should have been invested at 12% interest sinking fund for every year. Then by the end of the 10th year, there will be 1 million in the hand for the company. By realizing the investment, they can earn that as the money and pay the deposits. So this is called sinking fund. Right? You take down this and attempt the answer. So a bank has offered you an annuity 28,000 for 5 years. So A is identified 25. N is 5. P value is 1 lakh because today value. So what do you want to find out? N. N you want to find. Then what is the time value concept you want to apply? Annuity is involved, so annuity concept should be applied. So you want to decide present value annuity or future value annuity. So this time is present value of annuity. So answer 7.93. So again, you want to apply the interpolation, linear interpolation method to get that, as we have done earlier. You apply that as the linear interpolations method. So in the website, every detail is there. You can go and learn by yourself. So you set I. Uh, whichever value, the present value interest factor. And you can substitute and get that the value is equal to 4.000. But it is not available. If we take it with the formula, the task table, 4.000, 5 years. You go by these 5 years to find out them. Uh, so you have one thing, 3.99 is there, but 8%. Your answer may be given as 8% approximately. But it is a 0.1 is short there. So what can you do? You can give an exact one. At 7% is there, 8% is there. So the exact 4.0 in between this. So the linear divergence is set like that. So 7.93% is stance. You can check it with that the formula also. So you can get that at the exact 4.000. You multiply by 28,000, you can get one like that. So it's okay, confirm. So with that, we can conclude that the approximation 8%. So you can also find that exact one, or you can give a approximation for this kind of problem. So we can stop uh, this kind of exercises. Then we can go to the next topic. So the next class we can go to the lesson 3. So the document lesson 2 or lesson 3 would be uploaded. Then the lesson 4 is should be covered later. That is CVB analysis. CVB analysis would be continued. So everyone should learn this. Otherwise, you can't write that examination. The notes, that is a notes you want to take down and do the exercise. That is a notes you want to have. You can't do nothing with that as the notes for the examination.